Hello everyone, my name is Ben Prossman. I'm a student from the GU 103 class and a graduating mechanical engineer from St. Martin's University. The purpose of this video is to teach a little bit of the tools from Autodesk Inventor and show how they can not only apply to mechanical engineering, but also to civil engineering. A little bit of background on me is I am a graduating student from St. Martin's from this semester. And also, I have 2 years of professional work experience in a civil engineering environment. I have experience with hydraulic analysis, hydraulic design in regards to water mains, water treatment plants, such as slow sand treatment facilities, carbon plants, aeration towers, and also booster pumps, booster pump stations specifically. And that's the focus of my projects as well for GU103. While it's not typical, I used Autodesk Inventor to create a booster pump station. And while the booster pump station isn't technically up to code or anything that I designed, it was more of a way to demonstrate the power of Autodesk Inventor and how it can actually be applied to that process. Typically with if you're designing a booster pump station, you would use AutoCAD, and you would draw up the specs of the structure. You would show where you have your booster pumps, where you have your electrical, where you have your telemetry devices, etc. And the downside with that particular tool is that there is no the visuals are you have to be quite visual to understand where everything is typically, because it's all in a 2D sense or 1D depending on the drawing. The benefit of Autodesk is that for many people, especially clients, they want to actually have a good idea of what is going to be in place, and this offers a great opportunity to demonstrate your project to a client, not only to a client but to yourself and to your team, so you guys can have an idea of what exactly is going on in the mind of everyone regarding the project. You can identify piping within the booster pump station. You can identify where the control system should go as far as telemetry, as far as electrical, etc. So I'll be walking through with you some basic tools in Autodesk Inventor, and then I'll be also demonstrating my project for the semester and just showing you what you can actually do with using Autodesk Inventor in a professional sense. So as you see, here's your Autodesk Inventor menu. You have your tabs up here: 3D model, sketch, annotate, inspect, and etc. And each of these different tabs allows you to do different functions. Annotate allows you to annotate your sketch or your drawing. Inspect allows you to measure and do different other tools as well. And for this particular one, if you would like to change your units in your drawing and customize certain features, you can go into these particular windows right here and edit that. And your environments tab allows you to use different tools within Inventor, such as adding pipes, adding cables, adding electrical systems, etc., which is quite useful. And also, Autodesk Inventor has a basic finite element analysis tool as well, as you can see here. Now, my professor had asked me in the class earlier as to if Autodesk Inventor was able to do stress tests for structures and etc. And I've fully tested it to the extent, to any extent, to be honest, but I do know that you can do some basic tests on trusses and such. All right, let's get started. So first you're going to go to your sketch tab and click Start Sketch. As you can see here, you have your different planes to work with. We're going to just work with the XY plane today. All right, so now you have a clean slate for your sketch. Above here, you can see you have line. You can use the line tool, circle, arc, rectangle. You have different tools within this to edit your drawing. You have project geometry, which affects where you can change your plane. So let's say you have a sphere and you want to edit that sphere, but you don't want to edit the entire sphere. Let's say you want to edit the face of the sphere. This allows you to change the exact plane you're working with on that sphere. So let's say if I wanted to just cut the face off of a sphere at the very end of it, well, this would allow you to do that. All right. This tool right here allows you to dimension your drawing, and these tools are constraints. Now, I don't have time to walk you through every single one of these, but this is just the basics. And from these, though, it is very intuitive tools. These are very intuitive tools, and they're very easy to catch up on and learn how to use. All right, so we're going to build a simple structure right now. And I will walk you through how to do that. So we'll be using the rectangles and the lines. And from that, we'll be using the fillet tool, not necessarily the fillet tool, but the trim tool to edit that and get that where we want. And then we'll use the dimension tool to fine tune our drawing. All right. And I'm not necessarily going with any general dimension, but you can if you want to. But let's say if we're using a booster pump station, typically, depending on they can vary in size, but I'm going to go with, let's say, 20 feet or 25 feet in length or width. All right, so you can see there is your basic sketch so far. You can see you actually have constraints that show up already on your drawing. And now I'm going to also dimension. I click the dimension tool. I'm going to dimension this right here because 0.5 feet is no no height for any building. Okay, so we're going to do, let's say, 25 by 20 feet. All right, there we go. So we have 25 by 20 feet. I think 25 in this way, yeah, I think that makes sense. Okay, so now we are going to add a little bit of like I don't know, a space for a storage unit in there if you want to for tools, etc. So we're going to take another rectangle and we're going to click on the far bottom right corner from there, and it'll auto click to it. It has a snapping feature. And we are going to make a small room. I'm going to say 3 feet by, oh, that is not 3 feet. Okay. Delete that. 3 feet by 3 feet. And you got to be careful of your units. Let's see. 3 feet, 36, 36. Oh, and I just realized an issue with my own drawing is that my units aren't correct. So I mentioned the units tool earlier, and what we can do to correct this is go into your tools tab and go to, I believe, document settings. Oh, yes, and you see you have your inches right here. I'm going to change this to foot. If I can apply this, go back to my sketch. Now for me, I'm just going to delete this sketch since it's in inches. Now I'll start a new one, the same tab. And if you already had yours in feet, just keep it as is. I will quickly go through, make my new size. And as you can see, it has changed to feet on the screen and is no longer inches. So we're going to go 25 by, let's see, 15 or 20. All right, 25. There we go. 25 by 20. All right, so there is our sketch so far, as you can see. Okay, so from here, we will add on our little extra storage unit. This is just going to be an extension of the facility, obviously. We would go, let's see, and this could fit like, a closet or something. Not necessarily a closet, but something to that effect, at least. And 5 feet. Let's do that. We will do that. We'll do 4 feet by 4 feet. Perfect. All right. And so, or technically, you could even have a computer here. Just have to route your electrical systems differently or add electrical routing. Okay, so we're going to finish our sketch. And you can always use this to edit your orientation while you're out in your drawing. And we're going to hit the extrude function tool. Here's our different faces we can select. And we're going to click both of these right here. So building height, I'm going to do 9 feet. And click OK. All right, so our orientation of our building is not something we want. So what we're going to do is I want my building orientation to be like this from as a standard view. So I'm going to right click on the corner of wherever you want it, but it's up to you. I'm going to right click for this corner. I'm going to set current view as home. Fix to distance. Great. So now whenever I go mess up the view, I can always click home and this will orient the view back to how I want it. Okay. So now I will, this is obviously just a very outside block of the building layout for your booster pump station, for example. And we are going to cut out the inside area so it looks a little more like how we want it. So I will click Start Sketch, and I will select the top face of this right here. Zoom out a little bit. Okay. So now we're going to do another rectangle. And this is just very general dimensioning, everyone. But I can do a little bit more of an example of what dimensioning is. So we're going to click right there and right there. Okay, so there we have our rectangle for the outside face of the building. And now we will do the inside face. So I'm going to start a rectangle right there, and I just generically placed it. But from there, I will begin to dimension. All right, so I'm going to zoom in on my drawing. All right, so we have a distance between the two, and I don't want my concrete wall to be 8 inches thick. I'm going to go with half a foot. So we're going to go with 0.5. And as you can see, these are not quite correct yet, but they will be fixed. So firstly, what I need to do is dimension this to 25 feet. Not 25 feet, beg your pardon, 20 feet. So that way it doesn't mess with these particular dimensions. And then I'll dimension the distance between this wall, this line, and this line here. And I'll also do 0.5 feet. And there we go. 0.5 feet on all sides there. But we're not done yet. We also need to do it for this side as well. And so I'm going to, let's see, I'm going to make another rectangle or line, actually, in this case. And I'm going to zoom in on my, oh, it's a little bit of lag there. All right, and it shows up green for the snap. And I'm just gonna sketch along the outside wall here. The reason being is so I can actually define its constraints. There we go. All right, and so if you hover over here, you can see those lines are there. All right, I'm going to dimension the distance between this line and this line to be 0.6 feet. All right. Now I will demonstrate another very cool tool, and I'm going to extend a line through. All right. Click Escape. And now we have some extra lines here, so I'm going to trim that off using the trim command, and also trim this as well. We're almost there. Now I'll go to my rectangle tool and snap onto the edge there. And I'm going to just generically click there. And then we'll do the dimensioning again. 0.6, 0.5 feet, excuse me. And this is for all sides as well, 0.5 feet. 0.5 feet. Okay, and now we need to trim this right here. There we go. Now we have a complete sketch, and we're able to go through and extrude this. So go to your extrude command. As you can see, it's wanting to add material. We do not want it to add material. So we're going to cut. And we're going to cut it, not the full distance through, but we're going to just cut it 8.5 feet, let's say. Or let's say 8.75. Okay. So there we go. We have now a cutout of the inside of our building. We have a little extra storage space right here for tools or other such things. And we also have space to put our door now on this face of the wall. So to do that, we're going to hit Start Sketch and go here. Now, from here, I hit the rectangle command, click on a general place along the wall, and I'm going to do, let's see, the doors are typically 30 to 36 inches. I'm going to do 3 feet by 7 feet. There we go. All right. One thing though is that the way it's going to cut in, it's going to cut also the bottom floor out. So I should go in and edit that sketch so that we don't have that. So what I'm going to do is I'm going to dimension the bottom of the door. See, I'm going to draw another line right here so we can get that dimension correct. Dimensioning this to this. Oh, okay. Dimension this. Sometimes it can be a bit tricky. Okay, I need to delete this constraint first because it's messing with everything. Go through. All right. And I'm going to, instead of actually, let's see, I'm going to do right there. It's showing me, okay. Awesome. I'm going to trim this drawing. There we go. So what I did there was I don't want it to be all the way through the building. And that way when I extrude the door inward, it's going to cut also the floor out. And so you'll see in just a moment. So there's your door, extrude, we want to cut. And voila, there is your door. Now, I won't go much further on this particular drawing. If you wanted to, let's say, edit your materials, you have your materials tab here. If you wanted to, let's say, place different parts, like a control panel or generator unit, if you want, or let's say pumps, piping. Like I mentioned earlier, you have your environments here. And what you would do is you would save this part as a part and call it housing unit, for example. And you go here and click new. And here you have your assemblies. And from your assemblies, you can connect parts using joining commands, constraints. And I will give you a quick tutorial of what that is. So For instance, you can go through here, go to my project. As you can see, I already have a bunch of parts, for example, and we will take my other pre-made housing unit, open it up, zoom out, and you can see here's the orientation. And from here, you can right click and change the orientation on this drawing to get it how you want it. And we'll click there. All right. Escape. And then we will set again this to home view. Now, I went for a bit further on this particular drawing, and I put in a block there for a control panel. And also, I put in 3 blocks here, 1, 2, 3, all for booster pumps. These are booster pump pads, concrete, at which the booster pumps will rest on and be mounted to. Now, using the join command, you can join objects and apply relationships, which determine like motion. So you can have a rotating gear and you can actually see how it's going to act. Or if you just rather do a driven constraint without any of those play-by-play moments showing how your components will function, you can use the constraining command. And you can constrain objects to each other using different tools. Now, what you would do typically is you would take another object and you place it using the place command in here, and then you would begin your constraints in your joining relationships. Now, I will show you my example project after having done this for a few days of work. All right, so here is a completed project for this class. So here is your booster pump house right here. No roof, obviously, because we don't need that. We want to see what's going on inside. We have your booster pumps on the booster pump pads. You have your volutes connected to your motors. And you have a control panel here to do on, off, and run operations, with also cable running down the wall face and to these. A cool feature within Autodesk Inventor is its pipe and tube feature, which allows you to add in such things as valves. And here we have a gate valve. Here we have water coming in from the main line, going in through these booster pumps and being sent, continuing on its way to distribution. These tools you can see here are very intuitive. And the reason it mainly took me a few days to do this project, it normally take me a day or two, but the reason it took me a few days was because my project had crashed halfway through. All right, so that should be everything for this project. I hope you enjoyed the video. Thank you.